And this time around we will start the new unit, and the new unit name is unit dimension and measurement. This is the new unit we will going to start with. And in the given section, let's say the whole part it get divided into unit dimension next is error, and the last part is measurement. Total weightage 1 to 2 marks. This is the weightage of the unit, and we will going to start with measurement. And in measurement, this particular section is called as experiments. Now in experiment, uh, there are few devices like Vernier calipers, Vernier calipers. There is a next device that is called as a screw gauge, and we can say Ohm's law experiment. These are the few experiments that usually ask in your paper. So today we're going to see the vernier and screw gauge. So let's talk about vernier calipers. Calipers. So in vernier scale, the device name that we used to call as, so in vernier calipers. So in vernier calipers, you can say as it is given, that is the shape is very much this is the upper section, and this scale is called as main scale, and this is lower jaw, and lower jaw will having another scale that is called as vernier scale. So there is a lot of columns, and in main scale so Vernier scale and the main scale, the two type of scale were there. So in Vernier calipers, next segment that is called as least count. So least count is defined as what minimum it can measure. Minimum it can what minimum it can measurement. So like is in normal scale we can say least count LC is 1 mm. For Vernier calipers we can say least count is 0.1 mm, and for screw gauge the least count is 0.01 mm. Those are the standard one. So you better to remember via normal scale we can measure 1 mm, via Vernier calipers we can measure 0.1 mm, for screw gauge we can measure 0.01 mm. We can also convert into centimeters as well. So like 1 mm, that is equal to 1 divided by 10 centimeter, or we can say 0.1 centimeter, and 0.01 mm. So once again it is divided by 10, so 0.01 centimeter. Again once it divided by 10, 0.001 centimeter. So those values in centimeter. Now we will going to see the Vernier calipers first. So in Vernier calipers, let's quickly calculate least count. Least count is equal to a value of one main scale division, fine, minus value of one Vernier scale division. So least count it is defined as value of one main scale division minus value of one Vernier scale division. So let's take the main scale n division on Vernier Vernier that should be equal to n minus 1 division on main scale. Fine. So n division on Vernier scale should be equal to n minus 1 division on Vernier scale. So let's take one main scale division that is equal to x. So one main scale division is x. So n division on Vernier is equal to n minus 1 into x. So 1 division on Vernier is equal to n minus 1 into x divided by n. So 1 division on Vernier, that is equal to n minus 1 into x. So basically least count, once we put, like we have seen, value of one main scale division minus value of one Vernier scale division. So we will going to use this formula. So here we can say least count is equal to 1 main scale division minus 1 Vernier scale division. Once you have subtracted it, so you will get x upon n. So we can say that is value of one main scale division divided by total number of division at Vernier scale. N is total division on Vernier scale. So least count, it is defined as main scale one column divided by total number of division at Vernier scale. So usually one main scale division is of 1 mm divided by total number of section we have considered as 10 at Vernier, because nine division on main scale is equal to 10 division at Vernier. So once we divide, you will get 0.1 mm or equal to 0.01 centimeter. This is a least count, and that we have already seen the least count. I already told you the Vernier calipers, the least count is 1 mm or 0.101 centimeter. So by this way we can calculate the least count of it. Now similarly, here you can see, and let's calculate quickly how we will calculate the reading. So for the sake of reading, let's say this is a main scale, and here this is of device, this is called as jaws. Let's take, if I stuck anything in between the jaws, those are jaws. So first we have to take the reading of, so total reading this should be equal to main scale reading. Main scale reading plus there is some column that is coinciding, so number of line that is coinciding coinciding the number of line that is coinciding to main scale multiply by least count. So main scale reading plus number of line that is coinciding with the main scale multiply by least count plus minus 0 error. So let me quickly tell you, total reading is equal to main scale reading plus, let's say, number of line is p that is coinciding to p multiply by least count, fine, minus 0 error. So 0 error of two type, positive 0 error and negative 0 error. So this is the formula through which we can get the total reading of vernier calipers. Fine. And for the sake of rest of the calculation, like by this section that is used to measure the that is called as strip, that is used to measure the depth or depth of the beaker, we can say upper jaws. This is used to calculate the inner diameter, and this is used to measure the inner, that is used to measure diameter. So these are the few section, and there is the vernier calipers, and if any question it will come, we will surely discuss the question. So right now we can wind up this discussion. The next discussion we will see the screw gauge and the PYQs.